Number 15. A mass 1 is equal to 16 kilogram object and mass 2 is equal to 12.5 kilogram object are suspended, joined by a cord that passes over a pulley with radius of 10 centimeters and a mass of 3 kilograms. Assume the cord has no mass and does not slip on the pulley. The pulley rotates on its axis without friction. The objects start from rest 3 meters apart. Treating the pulley as a uniform disk, determine the speeds of the two objects as they pass each other. To start off this question, we need to find the angular acceleration, which we could use to find the tangential acceleration, which we could use along with our kinematics to find the speed at the crossing of these masses. So we're going to start off with our general torque equation. Net torque is equal to I alpha. And now there's actually two torques acting in this diagram here. We got one here, acting down. We got one here, also acting down. But notice that this force is going to be bigger since this mass is a higher mass. So I'll denote this as Fg1 and this as Fg2. So the torque of Fg1 minus the torque of Fg2 is equal to I alpha. Fg1 is positive because it would cause a counterclockwise rotation, while Fg2 is negative because it would cause a clockwise rotation. Now this is all nice, and we could substitute in what the torque actually is for these. So we got Fg1 times the radius minus Fg2 times the radius is all equal to I alpha. And since we know that Fg is just equal to mg, we could substitute that in. And now, I'm looking at this, we could solve for acceleration, but we need to know the moment of inertia. So starting up here, the net moment of inertia is going to be the moment of inertia of the disk plus the moment of inertia for mass 1 and the moment of inertia for mass 2. So for a disk, it's just 1/2 mr squared. And then for each of the different masses, it would just be the mass times the radius squared. So I'm going to write this as m1 plus m2 times the radius squared. And now that we have this equation, we can substitute in our known values. The mass of the disk is 3 kilograms. The radius is 0.1 meters. Mass 1 is 16 kilograms. Mass 2 is 12.5 kilograms. And again, the radius is 0.1 meters. Plugging this into your calculator yields a moment of inertia of 0.3 kilogram meters squared. Bringing this over here and substituting into our torque equation over here, just doing a bit of factoring on the side to make it easier. And dividing by the moment of inertia. Now that we have this, we can substitute in our known values and solve for the angular acceleration. G is just 9.8 newtons per kilogram. The radius again is 0.1 meters. M1 is 16 kilograms. M2 is 12.5 kilograms. And the moment of inertia is 0.3 kilogram meters squared. Plugging this all in your calculator yields an angular acceleration of 11.433 seconds to the negative 2. So this is all great. So we got the angular acceleration of the whole system, but we need to find the tangential acceleration of the masses. So to do this, we're going to start with our handy dandy equation. A is equal to R alpha. Because we know R, we know alpha, we're trying to solve A. So A is equal to the radius, 0.1 meters, times our angular acceleration of 11.433. And this yields a tangential acceleration of 1.1433 meters per second squared. So now I know what speed that the blocks are moving at. This mass is accelerating 1.14 meters per second down, and this one is accelerating 1.143 meters per second up. So to solve for the velocity that the masses will have when they cross each other, we're going to use one of our kinematics. Vf squared is equal to Vo squared plus 2a delta x. But the problem states that the system starts at rest, so we know Vo is just going to be 0. So we can cancel that out. Taking the square root of both sides. Alright, so we know what our acceleration is, 1.14 meters per second squared, but what's the delta x? You might be tempted to plug in 3, but that actually would be incorrect. If you plug in a 3, it means that both masses would be moving 3 meters. So that velocity that we would find would not be at the moment they cross. The delta x we actually need to plug in is 1.5 meters, because when each block moves 1.5 meters, they'll be crossing each other. So we just substitute in Vf is equal to the square root 2 times our tangential acceleration and plugging this into your calculator, rounding to 3 significant digits, yields 1.85 meters per second. When I first attempted this problem, I was confused with what to plug in for the delta x, because I solved for the acceleration, but I didn't know what to do. At first, I plugged in the 3 meters, like I was previously describing, and I was getting some weird answers. And then I tried to plug in an acceleration that was twice as much, because there were 2 masses accelerating, but that answer wasn't correct either. And then I realized that you would have to divide the distance in half, because both masses are moving simultaneously. And this problem shows my growth as a physics student, because it shows that I could take the torque equation and solve for angular acceleration, but then convert it into linear quantities and use it to solve linear problems using linear kinematics. Thank you.